Good morning, everyone. Good morning. Hope all is well. Hope everybody's doing okay. Hope you had a great weekend and ready to get this week started. So let's see. Last class we left off. I think we only did 3-1. Yep. So we're gonna get into 3-3 today. Normally I double back for 3-2 if we have time, but I like to get the ones that I know we need out of the way. So we're looking at 3-3 today. Dividing polynomials, remainder theorem, and the factor theorem.
So do we have to do 3.2 on MATLAB?
Nope, you don't have to at this point, though.
Okay, thank you.
All right, can we scroll up down the title? All right, we're gonna go through the long division process real quick. All right, so the long division process, we'll go through that real quick just because that is going to be the same process that we hold true to when it comes to dividing polynomials. So if I had this right here, 5,867 divided by 11, notice the setup. 11 is here and it's sitting on the outside of my long division sign. 5867 is sitting on the inside of the long division sign. So to make sure we hold true to position and what it means when we have 5867 divided by 11. So 11 is on the outside, 5867 on the inside. So you look at this 11 and you say 11 doesn't go into 5, but it goes into 58 5 times. So you're looking for how many times does 11 go into 58? 11 goes to 58 5 times because 5 times 11 is 55. That's the largest number under 58 that 11 can divide into evenly. So now we would subtract 58, subtract 55 from the 58. That gives us 3. Bring down the 6 or bring down the next digit. 11 goes, now we evaluate 11 into 36. 11 goes into 36 3 times. And that gives us 33. Largest number under 36 that 11 can get into, can create is 33. So 36 minus 33 gives us 3. Bring down the next digit, which is 30, which is a 7. That makes 37. 11 goes in 37 3 times, giving us 33 again. Subtract those, and then that'll give us 4. Excuse me, I didn't want to sneeze in your ear. All right, so that'll give us 4. Now the digit, notice we're finished here. Nothing else left. So that means that's our last number, and that last number is our remainder. So once you get to the end, then the last number you have down there is your remainder. And notice how we write it. That's 533. And then 4 over what you were dividing by, the remainder over what you're dividing by, which is 11. So that same process is the process that we're going to use when it comes to dividing polynomials. Questions? Any questions? All right, gonna scroll up. All right, let me erase some of this stuff so we can walk through it. All right. So we want to divide x squared plus 10x plus 21 by x plus 3. All right. So just like we did, what we saw before, notice the positioning of what we're dividing. This goes on the outside and this goes on the inside. All right, so now we're going to look at the first terms in each, x and x squared. You want to compare the two. You want to ask yourself what times x will give me x squared, or just divide out those two terms, x squared over x, and notice that gives you x. All right, once again, all you're doing is comparing the first terms. X squared divided by x will give you x. So that goes up here. Normally you line up the same power of your variable. Notice I have x over the 10x. I don't have the x up here. It doesn't matter because this whole space, is reserved for your answer. But normally you line it up with the same variable power, because then you'll come to the end of your problem and you'll be done. Everything will line up accordingly. So now I take this x and multiply it to both terms out here. So x times x is x squared. X times 3 is 3x. So don't forget to multiply this x to both terms out here. Just like the 11 was out there, we multiplied it to both ones. So that'll give you x squared plus 3x. Notice I put parentheses here because we have to subtract, just like we did here. Each time we have to subtract. So you're going to subtract both terms. X squared minus x squared is supposed to happen. That's what we need. That's why we did this, so that x squared can cancel. Then 10 minus x gives us 7x. All right, make sure we're okay with the process. You look at the first terms, you figure out what you're going to have as a first part of your answer. And you take that and multiply it to both terms out here. And that gives you x squared plus 3x. Distribute the negative. And now you have 10x minus 3x, which is 7x. Bring down the next number, which is 21. Now you have 7x plus 21. Once again, compare the first terms in each. And that's what we did right here. 7x divided by x is just 7. So that's what comes up here. Once again, you take that number, multiply it to each term out here. So that's 7x plus 21. Now you're going to subtract both terms. 7x minus 7x cancels. 21 minus 21 cancels. And that leaves you with a remainder of 0. And that's your answer. X plus 7. Any questions? Any questions? Before we do another one. All right, start again. So here we want to divide 4 minus 5x minus x squared plus 6x cubed by 3x minus 2. All right, so notice that they were written in ascending order. But here, this is written in descending order. So it's best to just write all of it in descending order, and that's what we did right here. So we have 6x cubed minus x squared minus 5x plus 4. Notice that whatever's positive stays positive, whatever's negative stays negative, as far as, rewriting the order. Mhm. So once again, you compare the first terms, 3x and 6x cubed. And that's what I did right here. You're saying what times 3x will give you 6x cubed, or in other words, 6x cubed divided by 3x will give you 2x squared. So that's the first part of your answer. Once again, you take that 2x cubed, multiply to each term out here. And that'll give you 6x cubed minus 4x squared. Distribute. So negative 1x squared plus 4x squared, because the negative to negative term is positive now. That sign's going to be positive. So that leaves you with 3x squared right here. Bring down your minus 5x. So now you compare the first terms again. What times 3x will give me 3x squared? It's going to be x. Put that here. Multiply this to both terms. That'll be 3x squared minus 2x. Distribute the negative. Always be careful because a lot of people make a mistake. They would distribute a negative, they cancel out that first term, but they forget to give negative to the second term. But that'd be negative 5x plus 2x. Bring down your 4. Compare first terms again. Negative 3x divided by 3x would be negative 1. Multiply that to both of these numbers out here. Distribute that negative. These cancel. And then you have 4. Oh, this should be a plus. I love that plus. Should be a plus right here. That should be a negative. Okay. All right. So that's 4 minus 2, and that gives us a remainder of 2. So we see what our answer is in the red box. We take what we have up top, which is 2x squared plus x minus 1. Then that's going to be plus the remainder over what we were dividing by, 3x minus 2. So that's 2 over 3x minus 2. Any questions before we do another one? All right. All right, next one, x to the fifth plus x cubed minus 2 over x minus 1. So notice we have missing terms here. We're missing x to the fourth, x squared, and x. So we need what we call placeholders for those missing terms. Do that. So that's what I have right here. I have x to the fifth, 0 x to the fourth. 0 times anything is just 0. So didn't change the value. X cubed plus 0x squared plus 0x minus 2. So whenever you need placeholders, you can put a 0 in front of that variable. And that will give you that spot. So what it does, it allows us to go through our progression throughout the process without any problems. All right. Any problems? All right. So now we would just follow the same process that we did in the previous two problems. Compare x to the fifth. I see that I read it over here. Nah. So x to the fifth. You said what times x will give me x to the fifth? It's going to be x to the fourth. Take x divided into x to the fifth, it'd be x to the fourth. So you multiply x to the fourth to both of these terms. That'll be x to the fifth minus x to the fourth. Distribute the minus sign. That turns positive, and these cancel. And that will leave you x to the fourth. Excuse me. Bring down x squared, x cubed. Excuse me. So bring down x cubed. And once again, you compare the first terms in each. X divides into x to the fourth. That'll just be x cubed. Multiply the x cubed to both terms out here. X to the fourth minus x cubed. These cancel. Turns that negative positive. And you're here with 2x cubed. Bring down 0x squared. Once again, you're always comparing the first terms. What times x will give me 2x cubed? And that'll be 2x squared. Notice how, like I said before, if you line up your powers, they'll continue to line up. So, all right, so multiply the 2x squared to both terms. 2x cubed minus 2x squared. 0x squared plus 2x squared is just 2x squared. Bring down your 0x. All right. What times x will give me 2x squared? That's going to be 2x. Multiply the 2x to both. That's 2x squared minus 2x. I'm trying to stay color coordinated. Distribute the negative. Then bring down minus 2. And what times x will give me 2x? That'll just be 2. So 2 times x is 2x. And times that -1, which is minus 2. And if you subtract both of those, you'll get a remainder of 0. So that would be our answer. Whole problem right there. All right, can I scroll up? All right, so make sure you try that long division process. If you have any questions, of course, bring them to class so we can do them. Or, as always, come to my office hours or set up an individual Zoom session. That's always an option. Okay. So let's look at synthetic division. All right, can only use when the divisor is in the form of x minus c. So in other words, the coefficient or the number in front of x has to be 1, and the exponent has to be 1. So if it's anything other than that, you cannot use synthetic division. So if you look at these 3 examples in the green, the first one, you can use it. Right there. So you can use synthetic division there because when you look at x, the number in front of x is 1 and the exponent is 1. In your denominator, we're talking about in your denominator. That's your divisor. Now, we cannot use synthetic division in the second one because we have x squared. And we cannot use this synthetic division in the third one because we have 2x. So if the number is something in your divisor, we're talking about your denominator. if it's something other than 1 in front of your x, something other than 1 as your exponent for x, then it is not, you cannot use synthetic division. All right. Let me scroll up. All right, so let's look at trying to use synthetic division. We have x minus 3, and we want to divide that into x cubed plus 4x squared plus minus 5x plus 5. So once again, synthetic division is an option because of our exponent and our coefficient of x. If there was anything else going on with x, then we would have to use long division, which is what we've done already. All right. Let me erase this stuff. All right. So first thing we would do is start it off this way. You would just have a little box to the left corner and everything will be empty, have a line. It would just be like this. You know, I put those pluses and stuff there. I'll just go ahead and erase them. So this is how you start it off. You're going to use the opposite sign of what you have with your x minus 3 in that box. So that would be 3. And then you will have, or use each one of your coefficients, 1, 4, -5, and 5. All right, any problems? All right, first move is to bring down this 1. Then you're going to multiply this 3 times 1. Take the result up here. Add them together. That'll be 7. And then you repeat that process. So then 3 times 7 will give you 21. Add these together. 16. 3 times 16 is 48. Add them together. And that'll be 53. Follow the process. So notice in the red statement, start with 1 exponent less than the original polynomial. So notice we started off with x cubed here. That means you start off with x squared. And we just use each one of these. And this last one is our remainder, just like before. So this is going to be x squared plus 7x plus 16, and then 53 over x minus 3, which is what we were originally dividing by. All right, questions? Any questions? All right, scroll up, but okay. All right, so here we have 5x cubed plus 6x plus 8. We're going to divide that by x plus 2. So once again, we use the opposite side of the number that is with x. In that box, and then we use each one of our coefficients. Notice we were missing the term of x squared. So just like before, we want to use a placeholder for that. So we put x squared as 0. So that's 5, 0, 6, and 8. Excuse me. All right. So go ahead and bring down your 5. I'm going to take this -2, multiply, and then take the result up. It's going to be -10. Add these together. There'll be a -10 down here. -2 times -10. +20. Add them together. 26. -2 times 26. -52. 8 minus 52. 44. -44. And that's our answer. Any problems? Any problems? Let's go up. All right. So the remainder theorem, the polynomial f of x is divided by x minus c, then the remainder is f of c. So in other words, when you take c and plug it into your function, you will get out the remainder. So I'll show you how that relates in a second. Just give me a chance to write. All right, so if they give us x cubed minus 4x squared plus 5x plus 3, says use the remainder theorem to find f of 2. All right, so before we, well, I'll give you a chance to write the problem. Give me a second. All right, so notice they give us f of 2. The only time we actually use the opposite sign is if your variable is with the x, like I showed you right here. So if we go back to what we did here, it was x plus 2, so we use the opposite sign. Here it was x minus 3 that they gave us, so we use the opposite sign. And that goes back to this right here. You know, if you were to solve your variable for your variable, it would be x equal to -2. And so that's where that comes from. But if they give it to you like this, then you just use the number that they have. So if it's not with x, you just use the number that they give you. So notice what you have here. You know, if it was x minus 2, that means that's the same thing as f of 2, the opposite sign. If you have x plus 2, it will be the same thing as f of -2, the opposite sign. So the only times you use the opposite sign if it's in this form, and it is with your x in an algebraic form. All right. Other than that, you would just use the number that they give you. All right. Is that okay before we walk through the process? So once again, because it's given to us in this form, we just use the 2 that they give. And use each one of our coefficients, 1, -4, 5, and 3. Bring down your 1. Two times 1 is 2. Add these together. It's -2. 2 times -2. It's -4. Add them together. It's going to be 1. 2 times 1 is 2. Add these together, that's 5. That's the remainder. Problem with synthetic division. Now, if the remainder theorem is correct, if I were to take this 2 and plug it into the function, I should get out 5. So our function is x cubed minus 4x squared plus 5x plus 3. Plug in 2. And our answer is 5. So if ever you want to know the remainder, you can just take that number, you know, the number that's in your divisor, plug it into your function. That would let you know what the remainder is. All right. Problems with the remainder theorem. All right, so here in that black box, just reminding you, or not reminding you, but just give you the lens on terminology. So your solution, 0, and root, they all mean the same thing. Your solution, 0, and root all mean the same thing. And so the reason why they call our solutions zeros, because when you plug them into your function, you'll get 0. And also that means if the remainder is 0, I mean, if when you plug it into the function, you get out 0, that means the remainder is also 0. So that's why they call solutions zeros. And that's why in this section, you will see the term zeros in this chapter. So we have the factor theorem, that f of x be a polynomial. if f of c is equal to 0, then x minus c is a factor of f of x. In other words, when you take your c, plug it into your function, if you get out 0, that means x minus c is 0. Notice you plugged in the opposite of what was with your x. And then if x minus c is a factor of f of x, then f of c is equal to 0. So it's just telling you either way. If you find out it's a factor, then that's a 0. If you plug it in, get 0, then x minus c is a factor. So in the green, just reminding you what it means to be a factor or what our factors are. All right, so I have x squared plus 7x plus 10. And if I were to factor that, it would factor out to give me x plus 2, x plus 5. And those would be our factors. X plus 2, x plus 5 would be our factors. Now, if I were to solve them, subtracting 5 from both sides, subtracting 2 from both sides, I would get my solutions, which are also called our zeros. Once again, that's because if I were to plug those values into our function, I would get out 0. And then if I were to use synthetic division on either one of those, I would get out 0 as a remainder. All right, questions before I scroll up? In the purple, I was just showing you that if you were to take one of those, plug it into your function, you get out 0. So that's what happened here in the purple. Take x equal to -5, plugged it in and got 0 out. All right, scroll up. All right, so here we have solved the equation. They give us 2x cubed minus 3x squared minus 11x plus 6 equal to 0. And then it says, given that 3 is a 0. So the red box is letting you know the 3 things or different things that come along with that statement. 3 is a 0. If 3 is a 0, that means x minus 3 is a factor. That means 3 is a solution if 3 is a 0. And that means also when I plug 3 into my function, I get out 0. So those are the 3 things that you would get from that statement. Also, a highest exponent for 3, a highest exponent is 3. So that means you should get 3 solutions. All right, so in the purple says we're going to use synthetic division to break down the function. All right, so let me erase this. So we will put 3 down because that's our solution. Then we use 2, -3, -11, and 6. Now, certain things have to happen if what they're saying is true. If they say 3 is a 0, that means our result from this synthetic division should be 0. Well, if that's going to be 0, that means this has to be -6. So I wrote those in there just to remind us that that has to happen or somewhere we went wrong. All right, because f of 3 is equal to 0, that means this column right here has to occur. My last number is 6 in my function. That means I need to have -6, and then that has to give me 0. All right. So we start by bringing 2 down. 3 times 2 is 6. Add those. -3 plus 6 is just 3. 3 times 3 is 9. -11 minus 9. I probably should have stayed with blue, but 11 minus 9 is -2. 3 times -2 gives us our -6. All right. Questions before we go to the next step? So we're going to solve the remaining equation. So we have 2x squared plus 3x minus 2 equal to 0. So I decided to go ahead and factor that. 2x minus 1, x plus 2. So if you solve those two, that'll give you x equal to 1/2, and then x equal to -2. And then also don't forget x equal to 3 is a solution as well. They gave you that one. And don't forget to put that as a part of your list when you write your final answer. Any questions? Any questions? All right, scrolling up. Better go with the last problem. Okay, so here, similar situation. 15x cubed plus 14x squared minus 3x minus 2 equal to 0. Given that -1 is a 0. All right, so line up using your synthetic division. That'll be -1 in the box, 15, 14, -3, and -2. And then you follow your synthetic division process, bring down 1, negative 15 times 15 will give you negative 15. I said negative 15. Negative 1 times 15 would be negative 15. That'll give you negative 15. Then 14 plus negative 15 will give you negative 1. Negative 1 times negative 1 is positive 1. Negative 2 plus negative 3 plus 1 is negative 2. And then negative 1 times negative 2 is a positive 2. Negative 2 plus positive 2 gives you 0. So once again, remember that had to occur if they tell us that negative 1 is 0. All right, any problems? So now we can go ahead and solve 15x squared minus x minus 2 equal to 0. All right. So factor that out, 5x minus 2, 3x plus 1. Solve them both, that'll be 2/5, negative 1/3, and then negative 1, which was already given to us. Any questions? All right, any questions on any of the problems, synthetic division, anything? Can I go to the next page? Everybody good? All right, well, we only have 13 minutes left, well, 12 minutes left. So I don't have to start a new section. That is, yep, that'll be good. That's a good place to stop. Anybody have any questions before we close out today? Everybody good? Everybody straight? All right, so you guys have a good day. Be safe. Next class, we will get into 3.4.
You too.
Have a
Thank you
good
so much.
day.
Thanks.
Thank you.
Take care. Take care. Bye.
Good day.
Please do the same.
Mr. Tucker.
Take